Now that we are approaching the designated lunch break, so take this as a light appetizer. My time with EasyBI approaches 1.5 years, and I come from an electrical engineering background, and some time ago you would have the opportunity to see me in a slightly different attire. In the time I took care of the projects and workflows of Jira and also Oracle BI reports and GIS data. Don't worry, the autobiographical part ends here. This serves as an insight on the twist to this topic. To the matter at hand. Building reports on different data sources consists of at least 3 parts. Data that you can tie together, getting it all in one data cube, and finally, creating reports that bring the different perspectives together in one place. Because of my electrical engineering background, this presentation has a twist inclined to electrical power line maintenance. Actually, the challenges faced in my previous position on bringing data from several sources together in one data model served as the main catalyst and inspiration. Let us have a look at the data we'll be working with. But before we dig into specifics, let us have a look at everything we can throw at EasyBI. For many, Jira is the main data source to analyze with EasyBI. Although quite recently, EasyBI has started the dating Confluence. Time will tell how that will affect this relationship. In addition, several of the most popular Jira apps have native integration with EasyBI, adding to the source options available to us. Integrations with other time tracking, project managing, and accounting applications, as well as SQL databases, REST APIs, and various spreadsheet formats. Quite the credentials, EasyBI. Now to specifics. In this use case, we will use Jira issues to track a project focused on maintaining and reconstructing electrical power lines, including the decision which ones need to go first, also serving as the main data source. To complement it, we will use the Inside Jira app and its custom fields to manage our assets, the power lines. And before you boo me off the stage for taking the easy way, we will add a SQL database to the mix. Now and then our electrical power gets disrupted, resetting electrical oven clocks or halting more serious matters. This information, the information on these disruptions, at least in high voltage networks, is registered automatically in supervisory control and data acquisition systems. I will use the abbreviation SCADA for these systems, and the data is collected in their databases. These systems help to operate the networks. That is where we will get the data to analyze one factor determining if a power line needs reconstruction sooner or later. So we will put all 3 of these into one cube. Let us have a glimpse on the Mindwell Insight app. Its main goal is to help you manage your assets right inside Jira. You can create different schemas to divide unrelated assets, for example, separate IT assets from human resources, or like in this example, electrical network assets. Assets or objects can be categorized and put into a hierarchy. For example, the MV line object that stands for medium voltage lines have substation switches as their parents. And you can see the full list of objects inside the category and the single object details. In our case, the name attribute stands for the electrical power line's unique ID. It is used in identifying the object and locating the object in electrical maintenance, everyday operation, and also in the SCADA system. We will use this piece of information in the data mapping as the tying knot. Other attributes can include links to parent assets and additional information about the object. In our case, some power line characteristics like length and dates built, last maintained, etc. Also, the changes made to the project and links to the JIRA issues where the object is selected in an inside custom field. Speaking of custom fields, a new inside custom field is necessary to connect the assets to JIRA issues. We will give it a name, construction object. Note that this inside custom field is a single value custom field that is deprecated. The reason we use this instead of the new inside custom fields, as of yet, EasyBI doesn't recognize them as single value. This is important as EasyBI can enable data mapping only to single value custom field dimensions. Select the schema from which you want to display objects, specify other filters if necessary, and select the object attributes you want to be shown in the JIRA issue view. This is one of the JIRA issues we'll be working with. Task type issues from a specific project with the necessary custom fields. The construction area represents belonging to a regional branch that is responsible for maintaining the power line. Estimated cost is a rough calculation on how much it will cost to complete the reconstruction. And the construction object represents our asset, the electrical power line. For the SQL source, it is not recommended connecting straight to the working database of a SCADA system. It can affect the performance of the and the data import might require data alteration or addition. A snapshot should be used instead. In our example, we have the fault element column. It represents the power line on which the fault happened. It will be used to map the data to the construction object custom field. And the date and time the fault happened will be mapped to the time dimension. For a start, this setup of only 2 columns could be sufficient. We will add more to it. With some numeric values representing the duration, affected customers, an approximate of the electrical energy not delivered to the customers, and a number of customer complaints tied to each fault. And lastly, an ID column. It is only necessary if you want to enable the incremental import for the SQL data source. Now that we know the data and the data points we will tie together, let us import it all into EasyBI. The JIRA issue and inside custom field import is straightforward. Select the project or projects in the EasyBI import options General tab, then in the Add-ons tab, the inside custom field. If necessary, select other custom fields and specify additional import options. In our case, we also selected construction area and estimated cost from the custom fields tab. Next, head to the EasyBI Advanced settings. To enable EasyBI to map data to a single custom field dimension, it is necessary to add the following parameters to the EasyBI Advanced settings. Don't forget to specify the ID of the custom field. After updating the advanced settings, you are ready for the first import. Now, let's add the additional data source. Let us add the additional data source, a SQL database. You can also use CSV and Excel files, Google Sheets, REST APIs as a source for the additional data import into the JIRA issues cube. With the SQL data import, first, let us connect to the database. By providing the connection parameters and credentials, and then the SQL statement to get the desired data from the database. Additionally, you can select the incremental import options. And now to the fun part, data mapping. Right from beginning, select the issues cube to import the data to. This will enable you to map the data to a dimension from that cube. Now let's decide how we will import our data. Default element column will be our key to the JIR issues cube. Let us select the inside custom field construction object, dimension, and level here. For the dimensions with several levels, you can select the appropriate one. Also, select the advanced option name column, as the name of the inside custom field is used for mapping. The skip missing option is recommended to skip the objects that are not in the JIR issues cube yet. Next, import the datetime column fault start as the time dimension. The data from the fault end column will not be used, but in cases the object appears only once in the data source, it can be mapped as a property on the linked dimension. In our case, the objects appear multiple times, as more than one fault can occur to a power line over time. Thus, the properties will be overwritten and only the last one retained. In the highlighted columns will be imported as measures. All measures you encounter in the later slides starting with the name fault are from the additional data import, all or calculated measures based on them. Lastly, the fault ID column will be selected as the source ID column. With the additional data import, this is only necessary and available for the incremental import. Now, let us import the data. If you see something similar to this, you are good to go. With the seemingly hardest part behind us, we move on to the part where the hard work comes to life. But stop. Do you think the measures from the additional data import act the same as the ones from JIR import? On the first glance, they do. With the time dimension on rows and only the construction object dimension with individual members selected, the results look fine. But once other dimensions are selected in detailed level, the values disappear. The reason for this is we map the measures only to the time and construction object dimensions in the data mapping. To overcome this, let us change the context of all the additionally imported measures by using the default context function. It will ignore the report context, meaning the selected individual members for all the dimensions, except the ones we specified inside it, will be ignored, and the default or all members used in calculating the measure's value. Specify the dimensions we mapped the data to, time and construction object. Now it looks much better. Do you notice the formatting change for the measure fault duration default? From a number disappearing in the whole picture, we now know what it means. Additionally, it could come in handy resetting the context for the time dimension for the issues created and estimated cost created measures. One to filter the reports for relevant values, the other to show the cost of the construction work on any date, not only when the issue was created. The first report to give us insight into which object to prefer over the other could compare the object fault count versus the estimated cost. To improve the perception, I will use the scatter chart. And the first two columns will be used as the X and Y axis. When the bubble chart option is selected, the size of it changes according to the other measures in the report. Hovering over the bubbles reveal more information. And already we can see some outliers where the investment seems more cost effective, meaning there is an opportunity to solve the source of most faults with the least investment. Adding other dimensions to the report can make it more colorful. And with the issue dimension in rows, you also get the option to go straight to the issues in Jira. To see the relation between number of faults and the energy that possibly was not delivered to the customers and see trends over time, first you can add trend lines with the EasyBI standard calculations. As the scatter chart does not support adding measures as lines or bars, let us switch to the bar chart. You can add a bubble to the bar chart. Select the type bubble. The measures right next to it will be included in the bubble, so be careful with the column order. Voila. Fault count measure determines the position on the X and Y axis, and the non-delivered energy measure the size of the bubble. We see that overall the fault count trend is steady, but the non-delivered energy trend is rising, and some big bubbles represent a high fault count and non-delivered energy, worthy of investigating. But overall, the deciding parties could use a ranking system that helps to shine the light on objects worthy of attention. Building ranking systems and setting the priority for each metric is a topic of itself. For this example, we will determine the weight of each construction object has for each metric in percents and use them as ranking points. You can use the standard calculation percent of total or create calculated measures for each criteria. Let us take the construction object A01. It has 4.6% from the total count of faults from the filtered set of construction objects in this report. And it seems the rest of the criteria is also around 4% and could give it a fair chance, except for the high cost. Let us have a look at the rank formula and in a calculated measure. The rank function evaluates the current member over the specified set by our criteria. In our example, it's the sum of all the additionally imported measure weight in percent minus the cost. And the calculated measure in action looks like this. You can sort the rows of the report by the rank. By adding the cumulative sum for the estimated cost, you can see which objects would fall in the limit, thus satisfying a set budget in a table or as a line chart. I can confirm no bones were broken in the process of building reports from different data sources, just a lot of coffee consumed. But it's always a good idea to wear a hard hat at a workplace. Before we part ways, a few takeaways. Not all your data lives in Jira, but that doesn't mean it can be friends with it. If you have a point or two to tie the data to, you can make it work. Prepare your data. Test the mapping preferably in a separate EasyBI account. And for the additional source, the delete data button is your friend. Delete the additionally imported data and make the necessary changes to the data mapping until it works. Try and try again. If all else fails, drop us a line. Thank you.